Hi, my name is Thomas Kim. In my previous video, I explained efficient permutation algorithm, how to enumerate permutation efficiently using loop. And I realized that loop implementation of permutation algorithm can be a little bit difficult to understand. So in this session, I will try to explain it using recursive function call. Usually recursive function call is usually slower than loop method. However, if we are using recursive function call, sometimes it's much easier to implement and easier to understand. So in this session, I will try to explain how to enumerate permutation using recursive function call. So basically, we are creating function like this. But say we have a set of, for example, 5 elements. 0, 1, 2, 3, 4, for example, like this. We can enumerate these elements like this. In permutation, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, like this. The first enumeration, we are selecting three elements from this set. Then it will be 0, 1, 2, and the second will be 0, 1, 3, 0, 1, 4. Now we reached the end here. Now we are moving to the next element. This should be 2, 1, 0, 2, 3, 0, 2, 4. Now moving 3, 0, 3, 1, 0, 3, 2, 0, 3, 4. Now moving to 0, 4, 1, 0, 4, 2, 0, 4, 3. Now moving it 1, 0, 2, 1, 0, 3. We are enumerating numbers like this in sequence, and I will label it as MC element. And we have 5 elements, and we are selecting 3. Then we enumerate. To give you a better understanding, let's say we have a set with 3 elements, 1, 2, 3, for example. We are choosing 2 elements, 0, 1, 2, 3, 4, 5. Then here we are selecting 2 elements, for example, 0, 1, 0, 2, then 1, 0, 1, 1, 2, here, 2, 0, 2, 1, like this. If we see it carefully, for example, we are given number m's, for example, we are trying to find this sequence, this permutation. If we see this has 3 elements, we are selecting 2. If we see this, we have 2 zeros, we have 2 zeros like this. We have 2 ones, we have 2 twos. Okay, 2 zeros, 2 ones, 2 twos. So basically, this permutation gives 3 times 2 times 1 like this. We can rewrite it like this. 3 times P21. 1 like this. Because this 3 means we have 3 elements here. 3 elements. We are selecting we are choosing 2 elements from a set of 3 elements. If in this set, if we are choosing the first one, we have 3 elements, so we can say if we are given m's, I would say 0 has 2 P1 zeros, 1 has 2 P1 twos, we have 2 P1 twos. So this means this number. Understand? So let's try once again. I will give you a different example. For example, let's see E equals 0, 1, 2, 3, 4. For example, we have 5 elements. We are choosing 3 elements from this set. Then 5 P2, 5 P3. In this permutation, this permutation gives us 5 times 4 times 3. Then we can rewrite it 5 times P 4 2 like this, minus 1 like this. This means the when we enumerate something like this, the zeros will the number of zeros starting with 0 will be 4P2 are zeros. 4P2 zeros. I have to say 4P2 zeros. We have another set. We have 4P2 ones. If we enumerate 1 blah 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 1 blah blah blah, this number is 4P2 ones. Okay, and the next set starting with 2 will be 4P2 twos. Twos will start enumeration permutation starting with 2 will be 4P2. 4P2 means 4 times 3. So 12 it will have 12 twos starting with 2. It will have 12 ones starting with ones. It will have 12 zeros starting with this minimum 0. For example, in this case, if we see this, this is 4. We are selecting 5, selecting 3 elements from a set of 5. It becomes 4P2 zeros. The first element, zeros. The next element starting with 1 will be 4P2 ones. So if we have index like if we call this index m's, for example 11, for example 11s, then we can decide this number like this. 11 divided 4P2 will be 11. This is 12. It means 0. Okay. So if we are going to choose 13s, for example, 13s, if we 13 divide 4P2, it will give 1. Okay. I mean quotient. Quotient is 1. So this number. This means this one. Index. So this is index of this set. For if we want to find, for example, 20 pips, for example, 20 pips permutation of this set. If we divide 20 pips times 4p2, it gives 25, 24, 12, it gives 2, right? The quotient is 2 because times 2 plus 1. This is 25. The quotient is 2 means the next element 20 pips permutation will start with 2, 0, 1, 2. Start with number 2, for example. So this basically means this. This basically means if we are given m's, if we are given number m's, like for example 11, we are selecting 5, 3 elements, 11. Then the first permutation, the number in the first permutation will be something like this. If I say index will be 11 over 4p2, like this, the first index. Okay. Then if we select one number, the first index, then the number shrinks. This set we select, for example, we selected 2, then we remove this, then the set E shrinks something like this. For example, if we choose in this, if we are choosing 20 pips, for example, M, then it gives 20 pips over 12. It gives 1, quotient 1. Then we are removing this element, 2. Then we are going 0, 1, 2. We are removing this element like this. Then E becomes 0, 1, 3, 4. Okay. Then this becomes new permutation. And now we set m's again from here. We set the remainder here. Okay. It means something like this. In this step, we try once again. It means m's. We compute index again. Index. Now we have 1, 2, 3, 4. Now we have 4 elements. When we started like 5, we did like n minus 1, r minus 1. So now we have 4 elements. We have to start 3. Okay, because we already choose one element here. We are choosing 2 elements. One element like this. Because we are going to choose here 3 elements. We choose 1. We are choosing 2 elements. So we have to 2 minus 1 like this. Then we have index 1, 3 over 1. It becomes 0. At this stage, remainder will be m's. This is quotient. Remainder will be 1, like this. Then in this set, the zeros element will remove this. Then we put here. At this step, okay, I will just let it do like this. We have to remove an element here, zeros element. Now we have we calculate index again, like this. The remainder 1. Now we choose like this 2, 0, like this. Then it becomes 1 because this number is 1. Okay. In this set, this is new set here. here we remove the zeros, then we have 1, 3, 4. In this set, we are choosing 0, 1. We are choosing this element. So here we are choosing, now starting back again. In this case, we choose second element, it becomes, we choose 0, 1, 2, we choose 2 number here, first case. And here, since we removed here, then we have 3 sets like this. Now select zeros, so then we select zeros. Now we remove it. If we remove it, zeros remove it, we have this. Then we select first 0, 1. Now we choose this one. Then 3. So 20 pips, and 20 pips, 0, starting with 20 pips, we have something like this. 2, 0, 3. This permutation we have 2, 0, 3. I hope you understand. I will turn it into a recursive function call, then you may have concrete understanding. So I will do like this. So we have this equation. When we are finding index like this. Index is n minus 1 r minus 1 over m's. Then we got remainder. We compute remainder like this. M's will be remainder. Will be percent modulo n minus 1 p r minus 1. This is the algorithm. So we are creating recursive function call like this. Vector int enum permu, I would say recursion. Like this, we are given n, r, m's. I will name it PR. Just short PR. Like this, n, r, m's. Then in this function, we will create a vector. This will be return value. Vector int, for example. It will be return set, return vector, and we initialize with reserve. How many elements we reserve? It will have r element like this. Then we initialize this set. So vector int, I will say e. Then we can have, it has n elements. This set has n elements like this. Then we initialize for since we have n element, okay, for int I equals 0, I less than n, plus I, I equals I. We are initializing 0, 1, 2, 3, 4 like this. Now we are calling this function, another function, recursive function, you see enum pr underscore like this. we are sending this function b, this vector b, then e, then r, then we are sending m's like this. We are calling function like this. At this point, this function computes the result here. We save the result here. Then we return b. Then the function ends. Here we have to implement this function. This function will be something like this. Void enum pr. Here we will get vector. This should be vector b e r m's like this. If r less than 1 means we have nothing to choose here. We have nothing to choose. Then we just return. Else say we are computing this number, for example, int index. We compute this number first. So I would say int. I will say this number npr. We compute. So we have permu gives npr this number, like say this is n is the number of elements of this set, so e size permu e size minus 1 and r minus 1. So this gives npr. This actually gives p n minus 1 r minus 1. Okay. Then we compute index int index. Index will be we have m's. M's over npr. Then we reset m's modulo npr. We compute npr here. Then we computed this. Now we are setting elements. We are moving elements from E to B. Okay, so we are moving elements like this. B. We are pushing back, in place back, or push back, in place back. Here, this is the set E. Now we have index here. Index like this. We computed index from this set, then this value is inserted to B, appended to B. Then we remove this element. Indexed element from here. To do that, we compute like this. ITR E begin plus index. Then it gives iterator for this indexed element. Then we say erase ITR. So we removed one element here. Now we are calling this function again. Now we are calling this function again. See here, enum pr here. So b e one element. Please note that one element is removed here. So e r we choose the one number here. So r should be r minus 1. It should reduce one number. And m's. So we have remainder here. We are passing remainder m's. So ends. And function ends. So this is recursive function call. It calls itself again with a reduced set. This is increased, this is reduced. And since we choose one number here, so the number of r should also reduce. And m's is also modified this way. So if this ends when there is no r is less than 1, then this function returns. Then at this point, this b holds the permutation we are seeking for. Now I move to my desktop and we'll code it in C++ code. If you haven't watched my previous video about enumeration of permutations using loop in C++, please watch this video. And also download sample source code. We are building, in this session, we will build on our previous solutions. Download it and unzip it. Move it to your working folder. For example, I will rename it. I will open this solution. If you open it, you can find the two solutions here. This is our previous one. This is actually I modified permutation loop. I will say startup. Then we will execute it. I already coded and I will explain it once again. Like this. Now we are making a new solution. I would say loop permutation. Permutation. I make a startup project. Add a new file. Loop permutation. This is our previous session. First, enumerate permutation. I will copy code from this project. I will copy all. Control A. Copy. Here I will paste. This is our previous project. Here. So you have to watch my previous video. In this video I implement enumeration of permutations using loop. In this session we are implementing using recursive function code. Now here I am adding code. This is new file. I copy and paste it here. Template, type name T. It is returning std vector T. enum permu. I say recursion. It will get n r m's. We will first initialize result set std vector T b reserve. We reserve n. I would have it like this. Size T like this. Now I declare a set E. It will have R n elements. No, this is R. This is n. I would say size T. Now we initialize set E. Size T n plus I E I T I like this. Then after this we will have set like this. E will have elements 0, 1, 2, n minus 1 like this. Now we are calling functions. We are ready. enum permu recursion. We haven't yet implemented this. We are sending B, E, R, M's. Return B. Here, template, type name T, void, enum permu recursion. We will have std vector T b std vector T E, then T R T M's. If R less than 1, then we simply return. Else T NPR we compute permutation permu. It will be E size minus 1, then R minus 1 like this. Like this. We computed permutation. Now we are compute index. We compute index like this. Size TS. M's divide by NPR. Size T M's modulo remainder NPR. Okay. Here we can say it can complain. For example, we can say like this if we want to. Then we are moving elements. move S element of E from E to B, like this. B in place back, E, S, we moved. Now we are deleting, removing auto, ITR, E, begin, plus S, E, erase, ITR. Remove S element from E. Now we are calling this function again, enum permu recursion B E R should be -1 because we have chosen one element here at this stage. The number of R, the choice should decrease by 1. Then m's. Also m's is adjusted here, the remainder. Now the function ends. So this is the basic way we implement recursion, recursively implementing permutation. It's a lot easier actually, the code, but it can be a little bit slower than loop method. You can try it. Now this is our previous solution. Here I will add a few more items. For example, I would say RDX, recursive index, enum permutation, enum permu recursion, and RMs. Here, I will copy it. Now I would say recursion, I would change it RDX like this. Now let's run. This is our previous session. You probably have to watch my previous session about this. Now let's run. This is loop method. This is recursion method. I will align a little bit. If you see this, this is loop, this is recursion. So the results are the same. So our recursion method works the same as loop method. If we are creating one function using for recursion, we are doing like this. If we just want to display indexes, you can say here. Here we can display all index IDX. Like this. And here also again rdx it is showing the index. So this is loop index gives us this is recursion permutation using recursive function call. This permutation using loop method, my previous video. So the results are actually the same. Before we conclude this session, I will finally optimize permutation. I will name it like this. Here I will copy it. I will change it into loop. std vector t like this. I will say permute, and it will be t and t r like this. It's final optimization. Now we will copy this part, this portion. I copied it here. Now here I need two more things here. Or n less than 1, or r greater than n. We cannot actually calculate in such case. Then we return. We cannot just return, we have to return empty set. We can return just b. Okay, and here we are changing it to loop. Now here while r means r equals not 0, it means here is correct. We don't need to change this. Here we are decreasing r minus r, then we don't need it. We can just loop like this. But we have to update this permute. See how we do that. Here if e size greater than 1, then npr t e size. With this we optimized. Here we have to return. We can return here. In fact, return b. If we want to use return value optimization, for example, we can further change it. Instead of doing this, I would say not. Then I will remove it like this. Then we don't need it. Return b. Now we try it. We try this algorithm. Here. Permute. I will say PDX like this. Now I copy it. No. I'll copy it here. PDX permute. Like this. It should be P. It should be P. Like this. I will make more changes here. And I will also change it here. Now let's run. Permute loop. We need this. This is permute, the function we just created, and they are exactly the same. See? The index exactly the same. Okay. And I will test more, a little bit more, because we have some errors. For example, we will put 0 elements. Crash. Because this is our previous, the first implementation using loop. We have to fix this like this. If no, okay, if we are copying this part, here, here, if, then we are calculating like this, and we can put it here. With this, it should work. Okay. And I will fix another one. Here also. This is recursion. Permute. This. Okay, it's okay. But what if R is less than 0? I think we better put it. We better put it to this part. This is better. Also here. It's okay. So this permute is most effective, efficient, most pettiest impact. I'll learn again. Here we are selecting 3. And 11, let's check 11s. Yes. And let's try, we tried with 1. If all works properly. Okay. Now 5. Okay. Now everything works perfectly. I will change it to 3. I will upload this code to comment section in YouTube. Please download this code. And please note that this is the solution you need to use. This is the fastest and most efficient. Thank you for watching. If you like my video, please subscribe, and I will film lots of good how can I say, lots of good algorithm. Thank you for watching.